Hey, what's up guys? Welcome back to the channel. And in today's video, I'm going to be starting a series of videos for one of my other projects. So, on a video that I posted a while ago, one of you said that you wanted me to create a devlog for a compiler. And so I thought I'd do something pretty similar. And that project is what I like to call the Uncommon Language Framework. And that name might ring a bell. It sounds kind of like the common language infrastructure. And that's basically exactly what it is. So you'll see it more as I get into the project. I've already done a lot of work on it, but I'll try to explain it as best as I can. So it's basically just supposed to be a clone of .NET, but structured in my own way. And so I made some questionable design considerations as I started this a while ago, which I'm not going to fix in this video. Maybe I'll fix it later. But I originally started this on another machine, so I'm just going to clone everything in here. There's like a heck ton of repositories. Let me just, there's like a debugger. There's the IL assembler. I probably should have just like made a mono repo for this, but you know, whatever. Let me just type it in instead of copying it. There's the standard library. Let's see. Yeah, there's like a bunch of other ones. I don't think I need them. Let me just clone this spec as well. Yeah, so these are a bunch of repositories that I need for the project. I'll be mainly working in the runtime one. I think I'm going to do some stuff with the JIT compiler today, but also be prepared to see my horrible commit history because it's highly unstructured, and I don't know, I've just never created another branch, so everything is on main. But maybe once I get this thing to be actually not completely useless and not just a hobby project, maybe I'll fix it up a little. But let me just make sure everything works. So I'll just code the runtime, and hopefully my VS Code pops up, and I will send this to front. There we go. Okay, that looks like it works. So as you can see, I have like random stuff here. I'll explain it in a minute. It's been a while since I've touched it, so I actually have to figure it out. But I also didn't like I didn't really want to install a build system, so what I did instead, which was kind of stupid, was I made a bunch of PowerShell build scripts along with, I think there's like oh no, that was on my other computer. Yeah, I made a bunch of weird build scripts that like cache object files. Let me just see if it works. I think I have to do this. Compile. Right, I need it. Okay, so I made like an object cache folder, but unfortunately that was in my git ignore. So I'm gonna have to make it manually. And then I think it was just cache. Put empty JSON here, and then lib cache and empty JSON. Yeah, this is pretty stupid. Are you kidding me? Wait, I have G++ though, right? Do I not have G++ on this computer? There's no way. Wait, are you kidding? Oh my god. Okay, I'll be back. I thought I had G++ here. Alright, hey guys, I'm back. I installed G++, I fixed up rmngw, and I fixed up my build scripts. So, let me... Alright, good, it's there. I don't know why PowerShell, like why is this allowed? I feel like this is extremely, like, also if I cd like C, alright, that's a bad example. Like if I want to go into Windows, right, I can do lowercase w and it autocompletes, which I actually like that, because if I'm typing on Linux and I do a lowercase letter, I hate that it doesn't autocomplete. But why are you allowed to do an uppercase G? Like this should not be a thing. Okay, regardless, let me go back into the ULR and then compile. Okay. Debug cache. Right. Wait, that means I need to debug lib cache as well, right? Debug lib debug. What does the debug cache have? Cache? Oh, okay, there's no lib cache. Yeah, it's been a while since I did. You know what? Maybe one video I'll switch to using a real build system instead of whatever the heck I made. That's probably a good idea. But this should work now. It's actually compiling. Wait, what? Hello? Are you kidding? Why are there compiler errors? No? That's an issue with C++. Like, you have one error and then, like, everything just, like, propagates from this. How did this... Did I accidentally, like, delete a space one day? Why is there an error now? Wait, did I install MinGW with non-POSIX threads? No, I did. Wait, what? pthread t is undefined. I included thread. Oh yeah, the garbage collector for this thing is like absolutely broken. That's something I need to fix. It basically just searches the stack for it just searches the stack for local variables, so like it could encounter a return address and like, oh wait, no, that doesn't make sense. It can encounter some random number, and if that happens to be the address of a variable, it'll think it's still in memory. But also, even if whatever, bad design, just know it's a bad design. I'm gonna fix it when we make the JIT compiler. But right now, I need to figure out. You know what? I'm opening up my other computer. Okay, I'm back, and I think I fixed everything. But I'm seriously considering porting this to a build system, but not today. There's one more thing I have to do, which is build the standard library so it actually works. And I'll switch to this window for that. Wait, what? Yeah, I do not remember what any of this stuff is. Okay. Whatever. So basically, I'm going to be focusing on this native folder right now. It's a bunch of just stuff written in native code, which is like ULR native code per se. So, what? Wait a minute. Oh wait, I have to add this to my include path in VS. It's in my compiler's include path, but include path. Where is this? I can't control F in here. Maybe I should just use the JSON. Compiler arguments, compiler path, browse path. Let me just add configurations JSON. Oh wow. Okay, workspace folder this, and then let me just find what I put in the environment variable. Bear with me, this will all work in a second. It will be amazing. Are you kidding? This is, come on Windows. Backslashes, I mean. They want to be different, but the issue, like, the fact that backslashes are the standard escape character exists. If it wasn't, this wouldn't be as annoying, but it's really annoying. Okay. This should work now. If I go to array, perfect. This should open up the source file. Yes. Perfect. Okay. So this is like quote unquote ULR C++, which is like it's like weird. So basically, for example, this is the constructor for array. It gets a size and an element type, and basically does stuff. Wait. No, this is just the array type. Sorry, this is the array type. Very weird stuff. It's been a while since I touched this. I know the string code better. String code, it's like, for example, the length property. I have this odd naming convention, but whatever. This is like string length. So like if you had like a think about C#, it's supposed to mimic C# and .NET. So if you had a string like that, like this would be effectively getting, when you get this property, it'd be calling this C++ function. So the size, so the way I set up strings was for every object, it's like the pointer width of the type. So that's for like vtables and stuff. And then specifically for strings, so like then it's like the rest of the object data. And then for strings, the object data looks like the length and then like a variable amount of data for the characters. So then here it'll be like skipping like plus pointer width. It'll be skipping the type pointer and then reinterpreting that pointer to an int, dereferencing that, which gives, first 4 bytes constitute the size. So that's like basically what this is. It's like cache system string type. So this is the assembly info file. And I originally made this weird metadata format plus these pointer exports that would basically pipe all of this code and this information to the like ULR runtime. So this is like public class string, inherits from object, no interfaces. I forget what this is. I think this is like the size, but that's like a placeholder size. Then it says like a field value of empty is static, public static, read only field empty, and then a length property, which has a single get function. So it's like the metadata, but now I realize that trying to do this all in native code is a bit dumb, so I'm trying to port everything to a JIT compiler. It's kind of weird, but hopefully I'll get there soon. Alright, now that's all left to do to get this up and running is to cd into that repository native, right, and then build a native library, I think. Right. I don't know, on my old machine I renamed G++ to G++64. I don't know why I did that. Wait, no, there's no native. Wait a minute. Couldn't find part of a path. ULF lib. Because I renamed the standard lib. Okay. Dang, this is like, I seriously should have organized this better. Now I have to recompile on the other side. Wait, no, it's launching another window. Oh my god. I still have it? Okay. I have to recompile on the other side, which will be up in a minute. Debugger. Oh. What did I just turn on? Okay. Okay. Finally that works. Okay, finally. Okay, now I can build here. Alright, it's generating all the object files. Perfect. And now we have, this is the native library from the runtime. So if we can search for some of the strings here, there's like, actually no, this won't have, this will have C++ strings. But this is the native library that we just built here. It basically depends on the ULF runtime library. So if we look, we should be able to find like string somewhere. I'm not gonna bother. But anyways, now I'm gonna switch my window back to the runtime. Where is the runtime? Hello? It's not letting me switch. Alright, I'm gonna close the native lib window. Okay, there we go. And now I should be able to run this field info test, and it better not fail. What? Alright, I seriously did not think it would take over an hour for me to get this up and running, but I think I got it. So basically there's this .NET project that runs the runtime through this hosting DLL, which is like from this source file, a bunch of stuff going on. So I'm gonna run one of my tests, which is the field info test. And what I'm gonna do is, well, I have the .NET, so it's gonna be in ULR bin. Is there no release? No, I'll just use debug net 8.0. Is there nothing in there? No, ULR. Okay. Why can't I? Oh, CD. I have CD open. Well, I just need to do this. So ulr.exe. I'm pasting this command line, these arguments, and then I'm gonna send the path to the native library. So that was annoying. So basically, if you look at the source file for this, it's like the N is the assembly file, so that's that's this over here generated from this code. Just run some tests. The S is standard library, which I compiled in the other window, and also the debugger, same thing. So if I run that, yes! Okay, finally. So everything's running. Now let me just make sure the IL test runs. Oh wait, load JIT assembly. This is where it all came together. I made a JIT assembly. I made it in plain text. Then I compiled it using the ULR assembler. Then I used the ULR JIT compiler to JIT compile that assembly to native code. And then I finally called the add function from it, which was amazing. And I could actually call this using ULR reflection, which I'll show you in a JIT call. This uses ULR reflection. So basically this is making by hand IL opcodes in bytes, so not from the IL assembler. Then it's compiling that into an assembly, and then it's getting the method right here, right, via assembly or via reflection, and it's going to invoke the method boxing these two integers. Cool stuff. So now if I run that, I should be able to do, I'm going to do IL test and then the JIT call.
You should pass all the tests. Amazing. Okay. Jitcall.dll. Yes, all the tests. And then finally the last one, which loads the JIT assembly and then calls the function. Are you kidding?
10 hours later.
All right, I'm back for the 20,000th time. I don't know what I'm actually gonna cut out of this video, but it's like my 15th cut. After debugging this for so long, I finally got everything to work again. So everything's ported back to my machine. Let me just switch my window back to the runtime. Beautiful. So basically, I can get to explaining this again. Wait, let me just add in my to-do. Oh, you can see here some beautiful code that has been run by the ULR. Urgent refactor project to not make it a complete pain, and let me just make a sub point of that. Use a build system. All right. Hopefully future me will read this and not say, and I'll do tomorrow, which is what I'm going to say right now. I'm doing this tomorrow. But let me just get into the code and what I'm going to be working on today. And as I said earlier, or maybe I didn't say it earlier because I've cut it out in post-processing. This project, I'm just going to like jump into it, code and stuff, and basically all the context that you're missing for this project will, I don't know, you'll get it along the way. So basically the program that I just ran was this thing, load JIT assembly. So you can see first, this is the path to my the standard library. It's written in like native C++, just like this, but it's like ULR C++. So it has some weird stuff going on like this, which is like the ULR metadata. Then this is the ULR debugger. I had that window up just now, and it doesn't want to go back up, but it was just there. That's just the stuff here that's like the debugger, so breakpoint, static breakpoint. And then there's the ULR, and then there's the actual path to the native assembly. So I'd use a -n, which is load native assembly, and this loads this native assembly. It's kind of like same type of concept as .NET assemblies. Native assembly has this one export, which is the entry point main. That's this. And then what it does is it loads the JIT assembly. So this assembly is literal straight bytes. So this is ULR-IL, and this intermediate language comes from a different file. I'll open it from, let's see. I have a UIL assembler right here. And you can see it comes from this file. So this is the actual human readable IL, so it takes a public class adder. Oh, by the way, this notation you might see like system in 32, whatever's in the brackets is the namespace, and then the thing outside is the class. So this, like, if it were .NET, it's right now it's Uncommon Language Framework. Theoretically, like, since this is a spin-off of .NET, what it would be in .NET would just be like adder, and then like the thing below would be system.in32. It's just that when I made this project, again, another weird design consideration, which I'm considering reverting. But anyways, it creates an adder, it creates a main function, or an add function, returns an int32, takes in two int32s, loads the first argument. So load, the APL is like argument past local. That's just what I named it. So it loads the first argument right here, loads the second argument, does an add opcode, and then returns that value.
So this is a stack. This is a stack-based language, just like CIL, like MSIL. So what it'll do is it like let's say A is like I'm just gonna give the arguments names. Let's say A is 0 and B is 1. What it'll do, what it will do is load A, so it'll put 0 onto the stack, load B, and then you encounter add. What add does is it basically takes, let me not use this, 5 and 1, so it'll load A, load B, then add will pop both of these arguments off, add them, and then replace the stack with 6, and then return will take this off the stack and like return it. So it is a stack-based language, and currently like it is like physically actually using the stack to like perform these operations. So it'll be using like the x64 stack to perform these operations. And then so what happens is I made this UIL assembler, which basically just transforms this into the bytecode form. So that's a bytecode form, and that's the same form that you see in the runtime. Let me close this window. Right here, that's the same form you see in the runtime right here. So the API loads this JIT assembly. What this does is it just turns it into ULR C assembly object, which like has a bunch of like metadata and whatever, and reflection data and stuff. So and it then like JIT compiles everything. So now it's whatever you saw before, like that adder class is gonna be loaded into memory, and the function will be JIT compiled as now a function written in native code in memory. So now what I'm doing is just using reflection to get the int32 type, and then getting the add method using reflection. So getting the adder from like using the metadata and everything. This is the signature to int32s, or the argument signature. Then I'm gonna output the offset. Then I just did a breakpoint, which for some reason now the syntax is acting up. And then I could call it using reflection, but just for simplicity, since I can also call it like as a native function, I can just cast the offset to a function that just takes 2 ints, because like int32 and int32 are internally also represented, just like in .NET, they're like struct types, but they're internally represented as value types with just int there. So I can just cast it to a native function, put some arguments, and then call it just like a native function because it's been compiled to one. Okay, so now I can do stuff. Let me just do this. It's gonna error out because I changed like the framework a little, but now I can actually run it. So you'll see that we're gonna hit the static breakpoint. This is actually the address that the JIT compiler has given, or has like allocated the function at. I can do some ULD commands, so I can say like p print cmeth class methods of the adder class. So you can see that's adder, which takes 2 system int32s, returns a system int32, and it's at that address. And then yeah, so then if I let this continue, you can see it prints out add of 4 and 5 is equal to 9. Perfect. So it all works. And so now I'm going to just go ahead and maybe I don't know, maybe I'll just do some stuff in the JIT compiler. And then I will end the video. So it's been a while since I wrote code for the JIT compiler, so I probably forgot like half of the assembly I used as well. Right here, compile type, and then compile section is where like all the cool stuff is. So the ultimate goal of like me writing the JIT compiler was to solve basically 2 problems. So originally I started out this project wanting like native assemblies. So theoretically, like the ULR compiler, I was gonna have like a C# spinoff called C Blunt. That C Blunt compiler would generate basically native C++, but like which use the ULR C++ libraries to effectively execute on the ULR. But there are a couple problems. First problem was I couldn't really generate generic code in the same way that .NET does. So I wouldn't be able to like generate generic code on the fly. Second one was garbage collection. I had no reliable way of garbage collecting objects, and so I needed to know where the objects were stored, and the JIT compiler will provide me info on that. So it'll tell me like which registers and for which functions and which like where in the stack for each function are local stored, and that will help me figure out where all the objects are, and so it'll help me make a real object or real garbage collector. So I did a lot of opcodes, you can see already, and this file is getting quite big, which is like why I don't know. I might have to refactor this. I already extracted a bunch of stuff. Like this all used to be one file. You know what? Maybe instead of implementing stuff today, I'll just go through every opcode and say what it does, and then that will have, and then you guys will have more context on the project. All right, so add, pretty self-explanatory. It just takes in like a type, like whether it be like floats 32 I64 uint64, and then it just adds them, pushes the result to the stack. Sub, same thing. Moldiv, same thing. I also have to add modulus or modulo. I don't know. I think it's modulo because modulus is like something else, right? It's like complex modulus or something. All right, cast numerical value, that literally just takes the last thing on the stack. You tell it. Oh yeah, here's another thing. This is differing from CIL or MSIL, which is MSIL. Like their JIT compiler actually checks to see that you haven't violated type safety. Yeah, mine doesn't. You just tell it what type is on the stack and it believes you. So you could say like, you just tell it what type's on the stack, what type you want it to become, and it just casts it to that type. Load string, same as MSIL. You pass it a string constant and it just creates a ULR object for it. Load numerical constant, pass it a numerical constant as well as the type of the constant, and it loads it as that type. Load field, this just same thing. It passes a type name and a field name. So essentially the fully qualified field name, and then it pops the last thing off the stack, interprets it as that type of object, and then grabs that field value and loads it. Load local. Oh, by the way, just one thing on load field. There's no weird, like I know Microsoft has stuff like load static field address and like load static field, and like they're all different opcodes, and like load field address. So mine doesn't have anything like that. If it's a reference type, it loads the address. If it's onto the stack, if it's a value type that's less than 8 bytes, or like fits in the pointer size or the stack like element size, it loads it onto the stack as a value. And if it's a value type that doesn't fit in that container, it loads the address, or it loads it into like temporary memory on the stack and then loads the address onto the stack. So it's like if it's struct and the value type does not equal 8, that's an unfriendly size. So it just actually loads the address of the field, which now I'm thinking is a bad idea, because wait a minute. If the field value changes, then this will be pointing to the wrong value. Okay, looks like I just found a bug. but whatever. That will be fixed later. Load local. That just same thing, just loads the local. Pretty easy. So you pass it the index, just like MSIL. Load argument, pass local, same thing. It's like load arg in MSIL. Pass it the index. Load element, not implemented yet, but same thing. Supposed to load a array element. Load. That looks like load list. It's load last, and it was just an opcode I put in here. That was just. It was easy to code. Just one instruction. All it does is whatever was last popped off the stack, it just loads it back onto the stack. So, oh yeah, all that takes is to subtract 8 from the stack pointer. So that was pretty easy. Call, we just went over this. Calls function. Store field, same thing, stores field value. Looks like I have not implemented it. Store local, self-explanatory. Store argument, self-explanatory. New array, self-explanatory, I hope. Return, self-explanatory. It just uses the last value on the stack to return as the return value. So many scopes. There's so many scopes. And then that's it. Wow. I really thought I implemented more. But then here's my list of actual opcodes. Yep, a lot to implement. Okay, now I'm just going all over the place. So I'm just going to end the video here. Hopefully you guys have a better idea on this project that I'm going to be working on and like documenting. It's basically a spin-off of .NET. And yeah, I'm writing the JIT compiler for it now. I've already implemented reflection and stuff like that, and I'm just hoping to do some cool stuff. But I probably didn't explain this very well because I was all over the place and just trying to get this thing to work. So if you have any questions, please ask me in the comments, and I'll see you in the next video where we're actually going to write some code.